It's glue. Ever wondered what keeps a massive skyscraper from toppling over in the wind, or how a bridge can carry thousands of cars every single day? The answer is all around us, in the hidden science of structural engineering. Today, we're diving deep into the world of construction structures, the backbone of every building you see. So, what exactly is a structure? In the simplest terms, it's any system designed to support loads and stay stable. Think of houses, bridges, towers, and even massive stadiums. All of them are carefully engineered structures designed to stand strong against forces like gravity, wind, and even earthquakes. Their job is to keep everything standing, safe and sound. To understand how they do this, we first need to talk about loads. Structures have a lot to deal with. First, there are dead loads. This is simply the weight of the structure itself, all the concrete, steel, and materials that make it up. Then, we have live loads. These are the temporary, movable things, like people walking around, furniture, or cars driving across a bridge. They come and go, so the structure has to be ready for them at any time. But that's not all. Nature throws a lot at our buildings too. Wind loads are a huge factor, especially for tall buildings. The pressure from a strong gust or a major storm can be immense. In many parts of the world, engineers also have to plan for earthquake loads, which are the powerful shaking forces from seismic activity. Finally, there are even temperature loads. As materials heat up and cool down, they expand and contract, and the structure needs to accommodate this movement without breaking. Each of these loads plays a crucial role in how a building is designed from the ground up. So, how do engineers design buildings to handle all this? These different structural systems, depending on the building's size and purpose. One of the oldest and simplest is the load-bearing structure. You'll find this in many smaller houses. Here, the walls themselves carry the weight from the roof all the way down to the foundation. It's effective but has limitations on how tall or open a building can be. For most modern buildings, especially skyscrapers, we use a frame structure. This system is like a skeleton made of columns and beams. The vertical columns carry the load downwards, while the horizontal beams support the floors and transfer the weight to the columns. This frees up the walls from doing any structural work, which is why we can have those amazing glass curtain walls on modern towers. There are other cool systems too. Shell structures, like domes and vaults, use curved surfaces to distribute forces evenly across their entire shape. This makes them incredibly strong and efficient. Think of the roof of a sports stadium or a grand cathedral. Then there are truss structures. You've probably seen these intricate triangular patterns in bridges or large roof spans. Trusses are surprisingly lightweight but exceptionally strong, making them perfect for covering long distances without needing a lot of columns. And for the most epic spans, like the Golden Gate Bridge, engineers use suspension structures. These rely on massive cables stretched under tension to hold up the bridge deck, too. It's a brilliant way to cross huge bodies of water, where building intermediate supports would be impossible. Now, let's break down the individual parts that make up these systems. Columns are the vertical workhorses, carrying compression loads down to the foundations. Beams are the horizontal heroes, supporting floors and roofs and transferring their loads to the columns. Slabs are the flat surfaces that form our floors and ceilings. And all of this rests on the foundations, which are designed to safely transfer all the combined loads from the building into the ground. To keep everything stable against side-to-side forces like wind or earthquakes, we add bracing. These can be diagonal steel members or solid concrete walls that prevent the building from swaying too much. So, how does an engineer put all this together? The design process is incredibly methodical. First, they study all the expected loads the building will face in its lifetime. Next, they select the best materials for the job. Whether it's concrete for its strength, steel for its flexibility, or timber for its sustainability. Then comes the math. They calculate the precise sizes needed for every single beam, column, and foundation to ensure they are strong enough. They check the overall stability of the entire system. And finally, they must follow strict building codes and safety standards to guarantee the final design is safe for everyone. This meticulous process ensures the building performs exactly as it should for decades to come. Of course, sometimes things go wrong. Structural failure is a rare but catastrophic event. It can happen for several reasons. A poor initial design, the use of weak or faulty materials, bad construction practices on site, or overloading the building beyond what it was designed for. Foundation issues, where the ground itself fails, or extreme natural disasters can also lead to collapse. V's. This is why good engineering, rigorous inspections, and high-quality control are absolutely non-negotiable in the construction world. And there you have it, a complete overview of construction structures. They are the unsung heroes that keep our modern world standing tall and secure. From the forces they resist to the systems that carry them, every element is a testament to incredible engineering. If you enjoyed this deep dive into the world of structures, please give this video a like and subscribe to our channel. We have a lot more coming up, with future episodes on foundations, beams, columns, and the entire process of building construction from start to finish. Thanks for watching, and we'll see you in the next one.